I fear these chairs are too comfortable and we're going to be too relaxed. Okay, you want to start by just one by one introducing yourselves quickly and what your project is?
Sure, happy to go first. I'm Ben, co-founder of Gensyn. Gensyn's a decentralized machine learning compute protocol. So we connect all of the machine learning capable compute hardware in the world together and allow it to be used as a resource by anyone who needs to train a machine learning model. You can think about us as, or the way that we think about ourselves is a fundamental protocol that underpins machine learning work, a bit similar to TCP/IP in the kind of traditional internet world. So we think the most important thing for the future of machine learning compute is to verify that the work is done correctly in a programmatic way and instantaneously. So if you send a chunk of a model to somebody's GPU, that chunk of model should be executed and you should get the results back along with the proof instantly without having to kind of human verify the work that's done. And we think that enables the next future of machine learning where it will be absolutely ubiquitous behind every single piece of tech we interact with. And rather than interacting with imperative code in apps and things like that, we'll be interacting with models that are probabilistic. But for that to happen, we need to have this instantaneous new protocol similar to the original web protocols.
Yeah, my name is Sophia. I'm a co-founder of Tromero. We are building a proof of useful work blockchain where the useful work is AI training. We started with an aggregator platform where you can rent GPUs and you can train your own AI models. We specialize in how you can do this easily and out of the box without you needing to deal with a lot of the communication that it's normally necessary for multi-node trading. That's probably it.
My name is Greg. I'm the CEO, founder for Overclock Labs and core contributor to Akash Network. Akash is the world's first supercloud that's decentralized. A supercloud is essentially a cloud that sits on private, public, hybrid, a single computer, and effectively provides you capabilities and features that would look like a normal cloud, and with a marketplace where you can source resources from places that you normally can't find in the typical cloud marketplaces. A lot of the demand for the recent past has been around GPUs. As you can see, GPUs are very hard to get, and according to Elon Musk, harder than drugs. So, but there are GPUs available in the wild, and Akash is effectively bringing a lot of that GPU supply to the market for people that need them. Right now, Akash, I bet, is the only platform you can get A100s and H100s on demand for sub $2. So we sell spice.
Thanks. So ever since I met Juan from Protocol Labs, I guess it was 8 years ago, he taught me about the idea of decentralized storage and crypto economic incentives. And I always imagined we'd be rebuilding basically like AWS, or GCP in a decentralized manner. I've been waiting for the decentralized compute thing to really take off. And I think I was sort of idealistically expecting it to happen for decentralization's sake. Okay, we need a decentralized version of this, we need a decentralized version of that. And maybe we do, idealistically we probably still do, but it seems like now, more than say 2 years ago, decentralized compute really, really matters. And I just want to get your takes on why and how decentralization matters now in a way that it hasn't in the past. Any of you who'd like to jump in? Yeah.
Sure, I can kick it off. I think we think about this in two separate ways, and I've explained this I think a few times this week. So apologies if people have heard it before, but I think there's a backwards-looking way where you look at the current compute market, and there's loads of reasons why the compute market just isn't good. Greg touched on some of them, like the supply chain dynamics. It's just hard to get hold of GPUs. It's hard to create GPUs. Once people do get hold of them, it's middlemen that sit on top of them and rent seek. Generally, the current kind of centralized market has lots of opportunities to capture a portion of the market for reasons that aren't really competitive. They're just kind of monopolistic practices, and it allows people to essentially print money off that kind of capture of that resource. Decentralization allows us to disintermediate that and essentially change the value chain so that it flows all the way back to the owner of the device instead of being captured by one of the kind of cloud providers that sits on top of it. So that's really nice. It generally smooths that market, makes it much more efficient. It allows us to use the world's latent GPU supply in a better way. So from our perspective, that's the kind of backwards-looking way. It just generally improves this marketplace. The forwards-looking way is thinking about what is AI going to become, and what's required on the compute side for us to enable the new machine learning future. And it's that ubiquitous point I mentioned before. There's going to be machine learning models that require heavy amounts of compute in absolutely everything we interact with. And the current centralized clouds just can't handle that load. The way of kind of going to an interface and booking time on a GPU and then triggering the training of a model within that time that you've booked as a person just doesn't scale to this future where every single interaction all of the people here have with technology requires that compute to just be instantaneously available. I think the only way we do that is pushing compute to the edge and having a distribution mechanism which inherently needs to be decentralized to access every single piece of compute and run the tasks that we need at that edge location, essentially. So yeah, there's some kind of lots of dynamics to the market right now, but there's also a lot of stuff in the future that we want to enable. And we call it the machine intelligence revolution. It's maybe a bit out there, but that's kind of the way we frame that future-looking view.
I think for customers in general, it's really important that you have a really quick response time as well. So distributed compute really allows you to be able to do AI training or AI inference, even more importantly, really quickly, as a resource could be anywhere near you. So actually response time, if your server is in Norway and you're here, it is going to be quite slow, and you can feel that with AI workloads. So yeah, that would be pretty important as well.
To add to Ben's answer here, yeah, the world is getting increasingly polarized and increasingly concentrated. If you think about, Amazon's, Google's of the world, and if you think about them being the biggest purchaser of data center compute and the number of data centers going down year, that means we are losing sovereignty over what arguably is one of the most important layers of our modern society that keeps us together, right? Which is the cloud. So, and what that is trending towards is a feudalistic society that we work so hard as a humanity to escape. Few people with the resource that everyone needs have control over those resources and charge a tax. All of us pay a cloud tax without even realizing we are paying a cloud tax. On average, 50% of all the income that online services make go to a cloud provider. And these providers are unelected companies with shareholders' profits and their prosperity as their primary driver, right? So if you think about AI now, and if you think about cloud companies being the gatekeepers of GPUs, like try getting a GPU from Amazon. It's impossible. You need to know someone that needs to know someone higher up to even get the decent amount of GPUs for you to train your model, right? So that's the situation. That's the scenario we have right now. And gatekeeping also goes beyond just stifling innovation. There's nothing new that's coming out of cloud that's more innovative anymore, right? What happened to this heavily distributed edge promise that we had 10 years ago? Edge is no longer a reality. Why? Because cloud decided to do hyperscalers because that's more profitable instead of actual edge. What happened to 10 millisecond latency at the network that we were promised, right? Nothing is improving. The only way to improve is to take it back and open source it and have people that use the cloud build it. So, and on top of the censorship is getting out of control, right? Because you fall under a different political spectrum, you could be censored for reasons that they don't even tell you what you're censored for. So we are in a very crazy political and socio-economical environment. If we don't decentralize, we will die as a society, and feudalism over freedom is going to prevail, and that's the reality we are faced with right now.
So Ben, you mentioned like renting a server and waiting, and you can't deal with that as a user from a UX perspective, and you're all sort of on a gradient of general purpose compute platform to very specific purpose compute platform. I'm curious about your thoughts, on either side of like what will make sense, because I think as a developer, as a person deploying software, and as a user, there are certain benefits to decentralized compute platforms playing very specific roles. versus general roles. And, like, how do you think about that? And how do you think about like training as one, inference as one, but then other specific possible decentralized compute, use cases that might make sense?
Yeah, I think we have a very specific view, which is if we're going to build this right in that forward-looking way, there's certain primitives that we need to get right. We need to solve certain problems properly before we can continue on and build that kind of new infrastructure. And so Gensyn's approach is to solve one specific one of those primitives very, very well. So we believe in the thin protocol thesis. If you're building a protocol in the Web3 sense, in this new way of building essentially open source protocols, you need to focus on one thing, solve that thing, and then around you, other protocols will solve the other pieces. And essentially what we get from that is this new stack that we can build on top of. And I think, like you mentioned, we all sort of focus on different ways of doing this and different places on that scale. Some of us will be closer to the end users themselves. Some of us will be further away. Gensyn's view is that we will be underneath. We'll be further away. Most users will forget about us, but people who are building maybe the front ends to AWS in the future can back off onto Gensyn at the fairest market price possible when they need to access compute for machine learning training. So we want to give people this new primitive that completely smooths the market, but only for this specific vertical. What that means is we're very happy to work with basically anyone who is doing any other piece of that. We're very clear on the bits that we want to do and the bits that we don't want to do. And I think we need people building those primitives, but we also need people building the interfaces and the things that build on top of those primitives. And in the future, we'll have a SageMaker that sits on top of decentralized compute. We'll have domain-specific model building interfaces that sit on top of decentralized compute, and they'll sit on top of decentralized data. They'll need general purpose compute, they'll need specific compute, but it'll all be these kind of protocols underneath that are very thin, all doing one thing really well. And that's how we completely kind of smooth that market. Otherwise, we're going to end up in a similar situation to we have in the centralized world, where people are able to capture portions of it just because of dynamics that aren't necessarily competitive. They're just kind of things that you can capture through capital and then rent seek on top of.
Yeah, I do believe that you need to be really, really specialized whenever you're trying to disturb the market. Obviously, the big players have a massive advantage over us. And in order to be competitive and in order to get demand, you need to be offering something better than they are. And that could be price, but it could be also ease of use, and it could be extra features that actually the big companies don't currently offer. I think the centralized players are very focused on specializing GPUs for AI training. So there is a lot invested in new architectures that accelerate compute. They're less concerned as to how this could be done in an easier way, or I even feel like they're a little bit distant from the reality of AI training and what machine learning engineers feel comfortable with, and how much AI has really changed over the past 2-3 years. So yeah, I believe that when you are building something, you need to think about how you can bring more value to AI companies other than just the GPU time and the price you can offer to them.
Yeah, you need to have full stack decentralization, right? So what that means is, all the way from resource acquisition to delivering the application in a manner that's consumable by the user, right? So all the way from GPU access to the layers in the middle when you have verification and fault tolerance and caching and load balancing and all the good stuff to the UIs and UXs of the world, right? So what Akash's approach has been general purpose compute. So we take a very unassuming approach and a very simple approach because at the protocol level, the more things a protocol does means higher attack surface, right? And also harder to scale. So we take a very, very simple approach when it comes to bidding or matching. And effectively, you can run a vector database along with your machine learning if you're training, or even a WordPress website with a SQL database, all in a single deployment, well orchestrated in a single namespace with network and whatnot, right? So by doing so, we allow for protocols or products to be built on top of that that bring their own specialized approach on how do you do verifiability. So for example, Gensyn is a phenomenal example here. Gensyn is focused exclusively on making sure verifiable machine learning is possible, but we take a more general approach where these both protocols can work hand in hand in a complementary fashion, right? So that's the future we look for. I mean, full stack decentralization is important. It's not one thing or the other. It's not special purpose or general purpose. I think you need both in order to really, deliver, because the trade-offs are obvious. The more general the purpose, the harder it is to do specific things. The more special purpose, the harder it is to do many things, right? So, but people always find solutions to build on top, and that's the beauty of what we do every day. Open protocols building on top of open protocols.
Thanks. So going back to the other end of the spectrum then, I'm almost unqualified to even ask this question, and I want to ask Sophie about the idea of reward functions in machine learning. And like you said, blockchain for proof of useful work, where the useful work is machine learning, which is a lot to unpack. How many of you are ML people in here, like machine learning experts? So only a few. So it might make sense to sort of describe what that means, but then, like in my mind, I think, does that mean that the reward function of the machine learning thing is the same as the crypto economic incentive, and can those things be the same thing, or what sort of problems would that cause? Or does that like make machine learning better in a way that it couldn't have been otherwise without crypto economic incentives?
Okay. Proof of useful work, I think many of you are most likely familiar with. It's basically you put the energy you have expanded as collateral for your verifying transactions. However, the work itself is hashing. It's not actually beneficial for anyone outside of the network. Me and my co-founder, we thought that this is quite stupid, and we can make it actually useful for a third party, and actually the game theoretics of it don't change. So what we do is we allow you to train an AI model, and then the energy you have used for that to put as collateral for verifying what has happened on chain. What this means is that miners and in general GPU providers have an extra incentive to be participating in the network. They get paid both from the AI training that it's being done from that third party, which is benefiting from the work done, and they're also mining cryptocurrency. The crypto incentives here are actually, I think, helping a lot. So the way we see it is that at around 2026, the GPU shortage bottleneck is gonna easen up. And when there is more supply, generally, hardware providers are gonna be having lesser profits. And by being able to do two processes into one and get the reward from both, they'll be able to increase their profit margins. We've constructed this as a way in which we incentivize hardware providers to stay with us. In general, on the topic of incentives and AI models, I think crypto is going to play bigger and bigger part of multi-agent systems. We will be able to incentivize AI models to do what we want them to do and behave in a way that we want them to behave by providing protocols and by providing incentive structures for them to behave in that way, which is, I think, something that crypto has been working with for decades. It would be able to be deployed for AI systems same way it's deployed for humans right now.
Any follow-ups on that, or should
I think I'd just add a quick, kind of cautionary point that I strongly agree that the crypto space has got very good at managing incentives, essentially. Like, crypto technology is a fantastic way of creating new incentive structures and incentivizing behavior that you would like to happen. But if we look back at all of the incentive structures that people have built in the past, it's very, very common that as soon as you add any complexity into that structure, you introduce a way where somebody will pursue that incentive in a manner that you didn't intend, and then you don't actually get the behavior that you wanted. And we've thought very, very deeply about this for the past 4 years in how you incentivize somebody to do the compute that you expect them to do. And there's lots of different ways that you can think of to do that, and a lot of them can accidentally incentivize the wrong thing. So the view that we have is you have to go all the way down to the actual lowest level thing that you want to happen, and you need to construct the incentive at that point. And it can be easier to construct a kind of proxy incentive that you think will push people towards that a bit higher up, but that doesn't solve the problem and ultimately leads to the outflows of the system not matching the inflows, and eventually that thing will collapse. So we've seen this many, many times before in the crypto space. It's a cautionary tale because I think people are going to fall into this trap again this cycle. And our message is basically just do the harder thing. Like figure out what the thing you want to incentivize is and focus purely on that. And that's what Gensyn does. And we have to solve the verification problem at a really granular level to do that. We wouldn't necessarily have to solve that if we created an incentive slightly higher up, but we don't think that would solve the problem. That would lead to kind of the wrong outflows and eventual collapse of the system.
So you've woken up my near sci-fi brain here, and Greg, I know you were about to say something. You probably will want to answer this one too. You are all enabling effectively what can be unstoppable compute, right? I love the word unstoppable in crypto. And when you start to marry it with incentive systems and how, like Sophie said, agents or AIs could be incentivized in different ways, and then you give those agents a wallet, and you give them access to the internet, and you give them access to physical infrastructure networks, what are the limits? And like, what in your dreams or nightmares that maybe aren't possible now, what things could happen? And don't leave out the dream part because the nightmare part's too easy.
I can take that. So on incentives, I agree with Ben. It's crypto it's phenomenal for incentives. At the same time, it's very, very wasteful, right? If you look at Helium, for example, I was an early Helium miner in 2019. I bought a device for about $300, and I minted enough tokens to be worth about $500,000 in about a year's time. I'm the wrong type of person to be incentivized to, I'll take the money, but I'm the wrong type of person to obviously get incentivized to provide, a small service, right? That's why it's very challenging to design incentives. Akash is pre-incentives. The reason we have not launched incentives, even though we have a huge budget, is because incentive design is extremely, extremely hard, and unless you get it right, you end up wasting. So we're doing several experiments, and happy to get into that later. On topic of unstoppable web, right? So, well, Akash in Sanskrit means the sky, and the name really came because sky is where the clouds are formed. The cloud of clouds, sky happened to be the super cloud. Akash, when you translate to English, of course, means sky, and AkashNet translates to Skynet. For those of you that are old enough to remember what Skynet is, for those of you that are not, it's the AI that kills us all from Terminator. So that was by accident. But what happens when you have an unstoppable? Hello, the best things are all done by an accident, right? What happens? You have an unstoppable network where agents can self-replicate by training themselves, and no one's going to stop them. And if you perfect the incentive structure, they can create incentives on the network, which will further scale up the network, and no one can stop them. I don't know the answer to the question. I'm bringing a child out next month, and she's going to grow up in this crazy world, and I have no idea how she's going to deal with that. I'll let her deal with that problem. But again, on a serious note, well, Akash is, built by the humans, right? So it's a proof of stake network where humanity has a stake, essentially. As far as I know, no bots own Akash tokens. Maybe they do, but as far as I know, it's mostly humans that run, and humans that vote on governance and policies. I don't see a reason why humans would not have some degree of proof of personhood as a prerequisite to use the network, right? Because again, as much as I a free market fundamentalist and a free speech fundamentalist, I do believe that free speech should be limited to humans and not machines, because as a humanist, right? So that could be me being biased, and 30 years down the line, maybe this talk will be, they'll be used as a way to suppress robotic speech. But I'm a fundamentally humanist, and I believe humans will do the right thing when given that they have agency to do the right thing, and not some 5 unknown board members that'll take over the most powerful AI for a few days, and we have no idea what's going to happen, right? So that's why I believe proof of stake networks or crypto networks are a lot more poised to prevent such a Skynet in the future.
Can I add something? I think the way incentives are being currently structured, they really don't care if you're human or if you're an AI system. And humans are really, really good at exploiting incentives as well. So if the incentive structure works for humans, I believe it's going to work for an AI system. I think the bigger problem becomes whenever, like right now, we know who to hold accountable whenever things go wrong. And the problem of AI systems creating AI systems is that you are not going to know who needs to be accountable if something goes wrong. We even have that problem whenever a human creates an AI system and we know who the human is. Because, I'm not sure that the programmer should be at fault. But yeah, I believe that AI systems are, whenever an AI is going to train on AI, at least in the way that it currently works, the resulting AI system is going to be worse than the initial AI system, just because errors are actually being magnified. It's part of the reason why data is quite so important and quite so valuable, because actually AI-generated data just doesn't really work. So that becomes even more problematic whenever in this world where AI systems create shittier AI systems and shittier AI systems and so on and so forth. And then they're more and more likely to actually making mistakes and being at fault.
Fascinating. I'm kind of worried for you, Greg, because eventually if systems on Akash start creating more systems and create more intelligent systems, they might find out what you said and come get you.
Hunt me down.
We have about 10 minutes left, and I thought it would be a good time to open up for audience questions. Do we have questions? Well, I know we have questions. Come on, don't be shy. There you are. Yeah, and we have a microphone for you, too. Thanks.
What do you think the best way for decentralized compute systems to handle private data is?
Happy to take that. Great question. I think that's, at the moment, not the biggest challenge, but will rapidly become one of the kind of biggest problems for decentralized compute systems. I think, realistically, the solution is software-side privacy technology. So encryption technologies, things like differential privacy, all secure multi-party computation, stuff like that. I think all of these things are pretty nascent right now. They're hard to apply, they're really fiddly, but they do work to an extent. And I think we'll just need more and more work into those technologies at the same time as a kind of progression in trust from people in those technologies. Right now, if you talk to somebody at like an enterprise about the idea of doing remote computation over data, but in an encrypted way, they trust it less than just local computation in an encrypted way. And I think we need to just generally increase the knowledge around these technologies so that people do realize, hey, actually, we can trust this. Maybe we can trust it up to a threshold, actually, but that's probably good enough for us to have to move these like compute tasks out into the world and towards the data. But yeah, generally, it's just a progression in encryption technologies and privacy-preserving computation technologies. And a lot of those they're kind of research level, and there's companies coming along that are productizing them, making them in a form that developers could just pick up and use. Zama are a great example, if anyone knows them, doing fully homomorphic encryption, taking what was previously just pure research and putting it in a productized form that somebody can apply. I think we'll see a lot more of that over the next couple of years, and a lot more, kind of a lot of an increase in trust in those technologies, and then we can start actually doing edge privacy-preserving computation.
I actually think if we look at technology today, we don't really have the ability to do that. However, big cloud providers actually share your environments with other users. Is the reason why if you are in a bank, you're less likely to actually use AWS to do your computations. So a lot of those companies that are very security conscious actually want to have their own dedicated server. And actually what a distributed network allows you to do is to have that dedicated server where you're not sharing the environment with any other user, where the hypothetical scenario in which someone decides to like break out of their container and then is able to see the data within yours is less of an issue. So it's an extra thing that could be offered by those distributed networks where in order to compete with big cloud providers as well. But yeah, I mean, I think the closest to privacy-preserving technology we currently have is TEs, and they still do slightly slow down things. But yeah, I think dedicated servers are the way to go until homomorphic encryption really is a viable option and the user is not impacted by the speed.
I think there are two issues here. There's privacy and then the security, right? So privacy can be solved by intelligent design. In case for Akash, we have the blockchain is a coordination layer, not a storage layer, whereas compute is off-chain, right? So the blockchain kind of is like a pointer that points to where the compute is, but the actual data residency happens on a computer somewhere. And now what is going to prevent people that have physical access to the computer from like snooping onto your data? That's a second level problem. Obviously, the first is, can you break multi-tenancy the computer's hosting, either through hypervisor multi-tenancy or through containerization? There are different trade-offs between what kind of tenancy you use on underlying, and then how do you secure the software? But of course, there's TE or trusted execution environments, which is okay, and then you can get go further down in terms of how you encrypt and whatnot. And an additional layer, like, is there a social aspect can we apply? Like, okay, can we dox the providers or have some off-chain verification mechanism where we identify the provider's identity in a decentralized manner? That's a solution that prevents and provides indemnity essentially in case something happens, right? So, Akash, right now we have a company called SolveCare, which is a healthcare network that stores HIPAA-compliant data, private, patient, U.S. patients' data on the network pretty safely. So there are a lot of interesting things you can do, and also U.S. Department of Defense use Akash internally to secure their servers, but they use a fork of the Akash network. They don't connect to the network, right? So technology, the software inherently provides privacy and security benefits, but again, it's a human aspect as well that's involved. So yeah, that's.
Thank you for asking what was exactly the question that needed to be asked. It was on my list. And I don't know who needs to hear this, but just in case you do, just because we say crypto doesn't mean your data is encrypted, right? Your data on public blockchains is public. And so it may not be the hardest thing to solve right now, or it might just not be top of mind. I'm worried that if we don't really think about this right now and start really implementing stuff, then we're going to do the same thing we did with the public blockchains and get a bunch of people really confused about where their data is stored. And we have a question here in the front.
Hey. Yeah, just a question on, like, as you're bringing on more and more people to provide their compute power, how do you go about verifying that each of these individuals, like whether developers or the actual compute themselves, has a good quality reputation and so forth?
Verification master there.
I can jump in. I think to us, reputation is a tool that's useful for certain things, but it's not necessarily the best tool for verifying that they're actually doing the work that they're doing. To do that, you need a real cryptographic, probabilistic verification system that looks at the work itself, because reputation systems can be gamed. Like, you think about like eBay feedback. It's a reputation system, but we all know it's essentially gameable. You can sybil it very, very easily. You can sybil most reputation systems. If you're willing to put money through it, there's essentially nothing that the system can do to stop you from gaming it. It can put in mitigations, but ultimately it's still gameable. So reputation to us is something that can be useful, but it's just a tiny piece. It's like if you wanted to slightly improve the robustness and security of a system that you can have a reputation system on top. Or if you wanted to guide people into understanding which provider they should use in a certain situation, you could maybe use a reputation system just as a kind of indicator for people. But ultimately, it's not a verification system. To do verification properly, you need to look at the exact thing that you're trying to incentivize to happen and verify that thing specifically. So that's why we at Gensyn talk about verification so much. We think it goes all the way down to the tech itself, and the gold standard is to have something like Ethereum where you can verify that each op was actually performed that was requested to be performed. And from there, you can build those systems on top, and you can have reputation for other things, but it's not a solution for a general purpose verification problem.
I'm not sure if you were implying that, but when you're talking about hardware providers and how you kind of like validate that they're actual users, we actually do KYC and AML checks for our hardware providers. We believe that if you are doing your computer on their hardware, they should be verified. We also run some tests to like verify that the hardware is actually what you like believe the hardware to be. Actually, there was some court case. I think I always forget which company sued them, but I think it was AWS suing Google. No, sorry. Rather, oh my God, no. Spotify suing Google for providing a GPU, claiming that it's a particular type of GPU. Turns out it's not. So even the giants do it, whether it was an honest mistake or not. It's worth like making sure that the hardware that they're claiming that they're providing to the network is actually the hardware they're providing. So we run a bunch of checks not only on the provider themselves, but also on the hardware. Similar to what Ben was saying, we do also like verify that the compute itself is legitimate and it's what you would expect. But in general, you actually are into the machine and you are doing your workload, so you're able to see if it performs the way you would expect it to. It's really, really difficult to realistically fake that. So if a user says this provider is saying that they have a particular GPU, and then whenever you actually try to do, let's say, multi-node training or multi-GPU training, as there aren't 4 GPUs, there are 3 or whatever, then the user will be able to pretty quickly catch up to it and then report it. So I think it ends up being a system, a scoring system where, yeah, if you're receiving bad feedback constantly, you're likely a malicious provider.
Right, so verification for general purpose compute is not possible yet. I don't know if there's a lot of research happening, but general purpose compute, that means you can run anything and everything. It's very hard. The closest you can get is probably using a resource hard function, and encrypt a cryptographic resource hard function, where only if you have certain resources that you can fill up the memory or fill up the CPU with that resource hard function, but that happens during non-execution time, right? At runtime, it's very hard to verify that you are actually getting the compute in terms of resources, right? The only way to verify is higher order function. So you got to go up the stack, like, are you getting the compute or the result that you're expecting to get the result? And then you have essentially a threshold benchmarking function where it essentially computes a few results, and based on that assign a reputation score. Unfortunately, general purpose verification is very, very out of touch. And even for the special purpose, right? If you look at ZK, I don't know what the new benchmarks are, but last I checked was for something like a stable diffusion verification, a ZK proof will take about 40 minutes to verify that the result came back exact. So if you're waiting 40 minutes before you can get your image generated, like, how will fake news propagate?
Okay, we are now exactly at time. So thank you so much to the audience for questions.